Hey guys, today we're going to be going over arithmetic series, which maybe sounds a little bit complicated, but I'm sure you guys know it's not as hard as it sounds. So, an arithmetic series or sequence is basically a list of numbers that have a common difference of the same amount. So, for example, in this list right here, it goes 4, 7, 10, 13. The common difference is 3, right? We're adding 3 each time we go forward. Now, this is a very important distinction you want to know. A sequence is literally just the list of them. A series is the addition of each term. All right? So, another thing you want to know is if an arithmetic series is infinite, okay, so if it goes on forever, then it always diverges. And that kind of makes sense, right? So if I keep adding, if I go 4 plus 7 plus 10 plus 13 plus 16 plus 19, ready? It's going to keep going to infinity. It's never going to converge to to one number. All right? So, but we'll go over that more in detail in a later video, but let's go over some examples. So, find the sum of the first 10 terms, 2, 5, and 8. Dot, dot, dot. So now, if you didn't know this formula, you would probably write down each term one by one. You'd be 2 plus 5 plus 8 plus 11 plus 14 and so on. And you'd get the right answer and it's not going to be so hard. But if I put this as 100, no one's going to want to write 100 terms. So that's where this formula comes in handy. And this is a formula you guys are going to want to know. So let's go over what each variable means. N is the number of terms. Okay. A is the first term. And then D is the common difference. Common, I'll just write diff. And then Sn is the sum of all the terms. Okay? So, this is something that we really need to know. So let's start plugging in what we know into our equation right here. So our first term, so our A is going to be 2, right? That's our first term. Number of terms, well, it's asking for the sum of the first 10, so n is 10. And now the common difference, well, to get from 2 to 5 and then 5 to 8, it's just 3. So the common difference would be 3. Now, let's plug this in. So the sum, and I'll write the sum of the first 10 terms are n, which is 10 over 2, times 2 over, or oh my god, I can't talk, 2 times a, the first term, which is 2, plus n minus 1, which is 9, 10 minus 1, times the common difference, which is 3, and boom, that's our answer. And if we simplify this, you're going to get 155. All right. So this is kind of an easier example. It's We're not doing calculus yet, but I think it's good to have this kind of basic foundation before we go into limits and when it converges and diverges. This formula is obviously very helpful. You're going to want to know this cold. And obviously you can only use it when there's like a common difference. If we had like 2, 5, 10, 12, you're not going to be able to use it because it goes plus 3, plus 5, plus 2. It's not a common difference between the terms. Alright, so now let's move on to our second example. Find the sum of 7 plus 10 plus 13 dot 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 plus 100. Well, this is an arithmetic series because the difference is constant, right? The difference is 10 minus 7, which is 3, which would be the same as 13 minus 10, and so on. So, here's the annoying part though. They gave us the last term, but they didn't give us how many terms there are. So first we have to find n. And this is where we use a new equation. So this equation would be an, which is the term of what, like let's say the 5th term, the 7th term, whatever nth term it is, of the first term, plus n minus 1 times the difference. And this equation makes sense, right? I have the first term, and I'm adding however many differences I have. All right? So, again, A1 is the first term, N is the number of terms, and D is the common difference. So, we can't use our first equation yet. Why? Because we don't know what N is. They didn't tell us, oh, there's 10 terms. No. They literally just gave us the full sequence. Or series, sorry. So what we're going to do, we're going to solve for n. So, well, we know an is 100, the last term is 100, equals, the first term is 7, plus n minus 1, and the common difference is 3. And now we just solve 100 equals 7 plus 3n minus 3. And now you're going to get 496 equals 3n, so n equals 32. Alright, great. So let's write that in this side over here. So n equals 32. So that's the number of terms. Now that we know that, oh wait, let me not erase that yet. That red formula is very important. You guys should write that down too. Make sure you memorize that. We can use our last equation that we had in the last problem. So it was n over 2 2a plus n minus 1d. So now that we know what n is, we can just plug everything back in. So n, I'm going to use blue. So the sum, right? We're finding the sum. The sum is n is 32 over 2 times 2. A is the same. The first term is 7. Plus 32 minus 1 is 31 times the common difference is 3. And now I'm sure you guys know how to do this. This will simplify to 1712. So the sum of this equation right here is 1712. So this is a very useful technique because I don't think any of you guys are going to want to add all of this by hand. Maybe you do if you're kinky like that. So by using these formulas, you kind of get a shortcut to finding the parts of the equation you need. So the first thing we did, we found n because they didn't tell us how many terms. In this example, they told us find the first 10. In this example, they never told us anything. So we had to find n by ourselves, and now that we found n, we had to plug it into our sum formula, and we got our answer. So now here's our last question. An arithmetic series has first term 5. Let me write that down. So a equals 5. The common difference is 4. Oh, and they gave us the sum. Okay, so the sum is 450. How many terms are there? So basically they're asking what is n, right? Because n stands for the number of terms. So in red, again, I'm going to use that sum formula, right? They gave us a sum, so I'm thinking we're going to have to use that sum formula. And the sum formula is n over 2, 2a plus n minus 1d. You guys are going to be writing this so many times. It's going to be second nature. You won't even have to think about it. So let's plug in what we do know. So we know Sn is 450. We don't know what n is, which that's what we're trying to solve. Now, the first term we know is 5, so this would be 10 plus, we don't know what n is, n minus 1, and we know d is 4. So now we're going to have to do a little bit of simplification. I'm going to multiply both sides by 2, so this would be 900 equals n times 10 plus 4n minus 4. So 900 equals n times 6 plus 4n, okay? Alright, so we see we're going to get a quadratic, and we will get 4n squared plus 6n minus 900 equals 0. Okay, I shrunk it down. Now, the next step I'm going to want to do, I'm going to divide both sides by 2, right? So I'm going to get 2n squared plus 3n minus 450 equals 0. And if I factor out, I'm going to get n plus 15 over 2, or times 2n minus 27 equals 0. So I get n equals negative 15, okay, or n equals 27 over 2. Now, we have a problem, right? Obviously, we can't have a negative number of terms. That doesn't make sense. How can we have negative 15 number of terms? And then, how can I have 13.5 terms? Like, I can't have half of a term. So what does this mean? This means that there's no arithmetic sequence with these exact numbers that gives a sum of 450. So it would be no solution. And sometimes this may happen, so don't freak out. But you want to make sure you can't just write, oh, I'm going to choose a positive and boom. How in the world can you have half of a term? How can you have 13.5 terms? That doesn't make sense. Alright? So, I hope you guys learned the basics. This is a very like foundational video on what you need to know. But I hope this video helped you, and if it did, please consider liking, subscribing. If there's any feedback you guys would like to give me, I'd really appreciate it if you put it in the comments below. If you have any questions, I'll answer them all, and I'll see you guys in the next video.